Okay, so operations of function notation. So when given multiple equations, you can label each equation with a specific function notation variable. So if I look at all three of these equations, they all have different numbers. So if I look, they're all different. So to represent them, instead of just having an f of x, which we can put for the first one, we can label the other ones with maybe a g of x, maybe an h of x. It could be a p, an r, a q, all of those different letters. But what these letters do is it gives them a different name. Just like me and you, we have different names because these are all different equations. So I have 4x minus 2, 5x plus 3, x minus 10. So that's why they all have different variables, because they're different equations. Now, with these equations and with these functions can be added, subtracted, and multiplied. And this is very similar to adding, subtracting, and multiplying polynomials, which we did last unit. Okay. Now, since we've done adding, subtracting, and multiplying polynomials, the only difference is the way that it's written. So function notation, the way that we write it is we take one equation, which is f of x, and add it to the other, which is g of x. Now, this notation right here can also be written as f plus g of x. The only thing we have to notice and recognize is that we are adding in both of these. That is the operation that we are doing. The same goes for when we are subtracting. We can take where it's written separately, and we can also put it together as f minus g of x. Again, the only thing we need to recognize is that in this one we are subtracting. And then the other one is our multiplying. So remember, our little dot means that we're multiplying. So this is f of x times g of x. And this can also be written together as f times g of x. So now that we have all of these notes filled in, let's go ahead and take a minute and let's try some of these examples. So they have given us two functions. They've said that f of x is 8x minus 5, and they said that g of x equals x plus 12. Well, if I look at this very first one, it says find f of x plus g of x. And so what's going to happen is the actual equation part of f of x is going to get plugged in to this part of our equation. So if I put parentheses, since it says f of x, I'm going to plug in 8x minus 5. And then it's going to get added to the equation that goes with g of x, which in this case is x plus 12. And again, going to go straight into parentheses. So this is going to get plugged in here. So x plus 12. And now if we notice, this is very similar to when we are adding polynomials. So we start from where our imaginary ones are, and we distribute that one so that way we can get rid of the parentheses. So 1 times 8x, that's 8x. 1 times negative 5, that's negative 5. Same with the second parenthesis. There's an imaginary 1. 1 times x, that's positive x. 1 times 12, that's positive 12. And now this is just combining like terms like before. So if I look 8x and 1x, they go together. 8x plus 1x, that's 9x. And then I have negative 5 plus 12. Those are my constants, which gives me positive 7. So now I have a new expression of 9x plus 7, and that came from adding f of x to g of x. Now, this equation does need a name, so we actually can pick any letter we would like, and let's just say that we pick h of x. This one can be named h of x. They're all going to have different names because they are different equations. Now, if we look at the next one, this one is written where it's together, but still, this is f of x minus g of x. So let me change my colors. It's supposed to be a g of x. So we have our two parentheses. What goes plugged in first is what f is, which is 8x minus 5. We are subtracting this time. And then my second parenthesis is whatever g of x is, which is x plus 12. And again, just like before, there are imaginary ones. We distribute 1 times 8x, that's 8x. 1 times negative 5, that's negative 5. Then this time there's a negative 1 in front of the second parenthesis. So I take negative 1 times x, that's negative x. Negative 1 times 12, that's positive, or actually, sorry, negative 12, my bad. Because a negative times a positive is a negative. And now we look and we start combining like terms. So 8x minus 1x, that's 7x. Negative 5 minus 12, that's negative 17. And again, this is a different equation by subtracting f minus g of x. So we need a new name. So why don't we just call this one p of x? So all I'm doing is just picking different variables so that way each equation has a different name. Now, for the very last one, this one we are multiplying. So if I go and I do the same thing, I'm plugging in what f of x is, which again is 8x minus 5. And then I'm multiplying it to what g of x is, which is x plus 12. And remember, when we are multiplying, we don't have to put the dot. When two parentheses are right next to each other, that is still multiplication. But this one, since it is multiplying, remember the one way that we multiply polynomials is through the box method, what we did last unit. So everybody, let's draw a box. Let's put our 8x minus 5 on the side, our x plus 12 on the top, and then we start multiplying inside. So this top left box, I have 8x times x, which is 8x squared. Remember, we add the exponents here. And then we have 8x times 12, which is 96x, I believe. And then the bottom left, we have negative 5 times x, which is negative 5x. And then the bottom right, we have negative 5 times 12, which is negative 60. Now I take everything out of the box, write it out, 8x squared plus 96x minus 5x minus 60. And now we can combine our two like terms. 96x minus 5x gives me 91x. Bring down my 60 and my 8x squared. So really, the only thing that's changed in this process is the way that our problems are written and making sure we plug in the correct function for each part. Now, this very last one I forgot does also need a name, so we do need to name this one. Let's just name this one r of x. We'll do r of x. There we go. So now, take a minute, flip to the next page, and I want you to try the next ones.